Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science, and in this video we're going to do a triple integral. So here we want to evaluate the triple integral over the region E of 6xy dv, where E lies under the plane z equals 1 plus x plus y, and above the region in the xy plane bounded by y equals the square root of x, y equals 0, and x equals 1. So first of all, notice that E is a three-dimensional region. Okay, it sits below the plane z equals 1 plus x plus y, and it sits above the xy plane, and the equation for the xy plane is z equals 0. All right, so what's significant about that? Well, that actually gives us some bounds on z. So z is below, or the region we should say, is below this plane and above this plane. So that tells us that 0 is less than or equal to z is less than or equal to 1 plus x plus y. Okay, so what's so helpful about that? Well, we're going to have to get bounds on x, y, and z in order to actually evaluate this. And we just found bounds on z. So how do we get bounds on x and y? Well, we're told that this three-dimensional region E sits above the xy plane, or sits above the region in the xy plane bounded by these three guys here. So let's go ahead and graph these three in the xy plane and see what it looks like. So when we do that, x-axis, y-axis, now we have y equals the square root of x, which looks kind of sort of something like that. And we also have y equals 0, which is just the x-axis. So this is y equals 0. And we have the vertical line, x equals 1. Okay, so the three-dimensional region E sits above this region in the xy plane here, bounded by these three guys right here. Okay, so how can we get bounds on x and y using this? Well, notice there are actually a couple different things we could do, but to make it a little bit easier on ourselves, let's say x goes from 0 to 1. So 0 is less than or equal to x, which is less than or equal to 1. And how about y? Now, y, as we move throughout this region, we see that y is bounded below by 0 all the time. 0 less than or equal to y, less than or equal to something. And also, as we move throughout this region, we see that y is always bounded above by the square root of x. Okay, so the upper bound on y is variable, so it's not a constant, it's the square root of x. Okay, so this is what we have going on here. So how does that help us? Well, now we have our bounds on x, and our bounds on y, and our bounds on z. So we can use all of those to write the integral now in a form that we can evaluate it in. So we have the triple integral over E of 6xy dv equals, now remember when we do triple integrals we have to work from the inside out. So the outer integral is the very last one that we do, and that one has to have the constant bounds on it because our final answer is supposed to be an actual number, and since the outer integral is the last one we do, then we have to make sure that that one has the constant bounds on it, or the constant limits of integration we should say. Okay, so the integral from 0 to 1, and then what's next? Well, what we should do next is the integral for y, so we should say 0 to root x, and then next we should do the integral for z, so that'd be from 0 to 1 plus x plus y, right? Why do we have to do it in that order? Well, because here, well, first let's finish this, 6xy, and then dv in this case is going to be dz, dy, and dx. Okay, so here we want to make sure that we actually integrate with respect to z first, because the limits of integration for z depend on x and y, so we have to take care of that first. Okay, so let's go ahead and go to the next page and work through this. So we have the integral from 0 to 1, the integral from 0 to root x, the integral from 0 to 1 plus x plus y, right? Yes, of 6xy dz dy dx. And from here we just integrate from the inside out, so let's go ahead and get to it. So we're still going to have the integral from 0 to 1, integral from 0 to root x. Now here, we're integrating with respect to z first, So we just treat 6xy, the entire thing, as just a constant. So really, as far as that inner integral is concerned, 6xy is a constant, which means when we integrate, we just get 6xy times z. And then we're evaluating this from z equals 0 to z equals 1 plus x plus y. And don't forget, we still have our dy and dx. Okay, now let's go ahead and simplify this. So this is the integral from 0 to 1, the integral from 0 to root x of 6xy times 1 plus x plus y, and then minus 0. Okay, so evaluate z at the top, that gives us 1 plus x plus y, and then subtract, evaluating it at the bottom, which is just 0, and don't forget our dy and dx. Now let's simplify a little more. We get the integral from 0 to 1, integral from 0 to root x. So let's go ahead and simplify and distribute the 6xy, and we get 6xy plus 6x squared y plus 6xy squared, and then we have dy dx. Okay, so let's go ahead and come up here. We're probably going to have to go to a new page soon. So this equals the integral from 0 to 1. Now we're going to integrate again, so we're going to integrate this one on the inside. Now we're integrating with respect to y, so all of the x's, we're going to treat them as a constant. And we have, so if we integrate 6xy, that's going to give us 3xy squared, because remember, 6x is just a constant. And then this one here is going to give us 3x squared y squared. Okay, because again, the x squared is just a constant. And then this one is going to give us 2xy cubed. And we're evaluating all of this from y equals 0 to y equals root x. And don't forget, we do still have a dx out here. Okay, so I think we're going to have to go to a new page now. So this is going to be equal to, let's go ahead and rewrite what we have, just to make this easier on ourselves. 3xy squared plus 3x squared y squared, and then plus, yes, 2xy cubed, evaluated from y equals 0 to y equals root x, and we still have a dx there. All right, now so we still have the integral sign for x. Now let's evaluate at the top, and then we're going to get 3x times root x squared, which is just x. And we have plus 3x squared times root x squared, which is just x. And then plus 2x root x cubed. So root x cubed is x to the 1/2 cubed, which is x to the 3/2. Okay, so this is going to be 2x times x to the 3/2. All right, and then when we evaluate at y equals 0, notice that everything is just going to be 0 because of all of these factors of y that we have. So here, we're going to have 3x times 0 squared plus 3x squared times 0 squared plus 2x times 0 cubed. So all of that's just 0. So nothing really going on there. And then don't forget dx. So let's simplify a little bit. And we have the integral from 0 to 1 of 3x squared plus 3x squared times x, which is 3x cubed, plus 2x times x to the 3/2, so that's going to be 2x to the 5/2, and then dx. Now this is pretty much just a standard calculus 1 type integral. So if we integrate 3x squared, we get x cubed. If we integrate 3x cubed, we get 3/4 x to the 4th. That's a 3 right there. And then plus 2 times 2/7 x to the 7/2. And all of that is going to be evaluated from 0 to 1. Okay? And luckily, this actually isn't too bad. So if we evaluate at x equals 1, we're just going to get 1 cubed, and then plus 3/4 times 1 to the 4th, which is just 1. And then we have plus 2 times 2/7 is 4/7, so I'll write that. And then we're multiplying by 1 to the 7/2. And then here, we're going to subtract and evaluate everything at 0. Well, 0 cubed is 0. 0 to the 4th is 0. 0 to the 7 halves is 0. So everything is just 0. Okay, so let's go ahead and come up here and then simplify to get our final answer. So 1 cubed is 1. 1 to the 4th is 1, so we have plus 3/4. And then 1 to the 7 halves is 1, so we have plus 4/7. And we're going to want to get a common denominator to simplify, and our common denominator is going to have to be 28, it looks like. So 1 is 28 over 28. And then what we're going to do here is multiply by, oops, I want to change colors there. Multiply this by 7 over 7, and this by 4 over 4. So this is going to be plus 21 over 28, and then plus 16 over 28. 28, okay. So then what we have is 28 plus 21 plus 16. So 28 plus 21 is 49. 49 plus 16 is 65. So this is 65 over 28. And can we do anything to simplify that? Let's see. 13 times 5, 7 times 4, nope. So 65 over 28 is our final answer. All right, so this has been an example of evaluating a triple integral, and I hope you found this video helpful, and thank you for watching.